Hey, good morning. Nice to see you here. Today is December 18th, which means we're on day 18 of Advent of Code. And yeah, today is Friday. Things are going well. How are you doing? Are you excited? It's almost weekend. I am a little bit. Yeah. So yesterday we left off with day 17. We finished the first part and almost finished the second part as well in the stream. I just had to do a last thing, which I did off stream, and I uploaded the code in case you want to see it. And I did a little bit of refactoring as well. So where we left off is we were at the second part. We expanded our four-dimensional grid, but we had to get the neighbors. So here's the kind of like the code that gets the neighbors for the adjacent cubes, which is two nested loops in here. One for the adjacent cube and then one for each slice of that cube. And then it gets all the neighbors, and then it filters out the active cubes and just sums it up, same as the first part. So that's what I was doing yesterday. And I also spent some time doing refactoring and extracting some common logic into functions, such as creating Y lines and empty Z slices and expanding them and so on. So yeah, later I found out a friend of mine, he approached this problem in a different way. I'm gonna link it in the chat in case you're curious. But what he used is he just used a couple of nested loops for the logic for getting the neighbors. But instead of a 3 or 4-dimensional array, he used an object, and that object had the keys were the coordinates, so x, y, and z, and the value was just the value of the cube, which was a much neater way, because going from part 1 to part 2 with this approach, you just need to add another 4 nested loop, and that's about it. It's much more straightforward than what we did, because I had to, for all of a sudden, instead of dealing with a 3-dimensional array, it was a 4-dimensional array, which made things a little bit more complicated down the road. But this is much nicer, and I'm definitely going to keep it in mind for future time I encounter something like this again. And yeah, I do recommend you having a read. He explained what's going on and how he's approaching this, so it's really insightful. Yeah. So that's that, and that's that. And I think we can just yeah, let's go. Let's get started with day 18. I got my setup code here copied from yesterday, and yeah, we can do it. On the map, where are we? We kind of left the island. We're still in the airplane. I think this might be our destination island. Not sure. Let's see what today is about. I'm excited. Day 18, operation order. As you look out the window and notice a heavily forested continent slowly appear over the horizon, you are interrupted by the child sitting next to you. They're curious if you could help them with their math homework. Oh, math. That doesn't sound good. Unfortunately, it seems like this math, quotes, double quotes, follows different rules. And then we are linked to a YouTube video. Math is math. All right, from The Incredibles 2. What does it say? Wait, let me.
Want us to do it
I don't know that way. Why would they change math? Math is math.
Okay,
Math.
Math is math. Why would you change math? Different rules, yeah. Then you remember. The homework, which is the puzzle input, consists of a series of expressions that consist of addition, multiplication, and parentheses, just like normal math. Parentheses indicate that the expression inside must be evaluated before it can be used by surrounding expression. Addition still finds the sum of the numbers on both sides of the operator. Addition is still addition. And multiplication still finds the product. Alright, however, the rules of operator precedence, which is in bold, that's kind of like a clue for our puzzle for today, have... hey Lars, nice to see you here. How are you doing today? Oh, good? operator precedence have changed. Rather than evaluating multiplication before addition, the operators have the same precedence and are evaluated left to right regardless of the order in which they appear. Okay, so that's different from math, the normal math. Addition happens, it's the same precedence as multiplication. All right. For example, the steps to evaluate the expression 1 plus 2 times 3 plus 4. You know, on Facebook or other media, you had like this very popular post that people would post, like, okay, what is 44 plus 3 minus 2 times whatever? And then a bunch of people would reply, and everyone had it wrong. And then there was discussion. It's like, no, it's super simple. This is the right answer. No, that's not the right answer. And it was some tricky thing. It had to do with order of precedence, because multiplication would go before plus, or there were some parentheses that people were missing, or something like that. So that's pretty funny. That's kind of like what reminds me of it. Are as follows. But here, this is all the same precedence. So we do 1 plus 2 is 3, times 3 is 9, plus 4 is 13, times 5 is 65, plus 6 is 71. Parentheses can override this order. For example, here's what happens if parentheses are added to form 1 plus... oh, good, thanks. Yeah. 1 plus 2 times 3, 6. 5 plus 6, 11. 4. And then... yeah, that makes sense. Good. Here are a few more examples. Okay. Before you can help with the homework, you need to understand it yourself. Evaluate the expression on each line of the homework. What is the sum of the resulting values? All right. Whew. That's a nice input for today. Let's grab it and save it in our working directory. Have you made any progress with Advent of Code, Lars? Or are you still fighting the transpiler? So we have our puzzle input in here, and what I'm gonna do as well, so I'm gonna create a new file for the example input, just so we have something to test with. Let's grab this one. Okay. So no, yeah. Do you plan on finishing it, or just like take your time next year or so? No rush. Yeah, only a few people do Advent of Code for the leaderboard, which is insane. These folks in here, the top 100, these are really clever people. But they've done competitive programming for so long. They really have some experience under their belt. So what we're gonna do first is we're gonna split our input by new lines. So we have that. We have an expression. Transpiler doesn't handle order of precedence correctly. It actually works much like this puzzle. It's a bug. Oh, that's nice. So a bug is a feature in this case of the transpiler. You don't need to do anything else. It just follows the puzzle's rules. Competing with the people on the leaderboard is a different ball game in general. So we got our array here. It's going to be individual lines of what do we need to do? What's our answer? Expression in each line. What is the sum of the resulting values? Okay, so we need the sum of them. So we need to evaluate this expression. That's interesting. I've never done something like this. Never done something like this before. So we need some logic to parse our expressions and extract the meaningful stuff out of there, and and then we can do math and compute whatever that expression is. So for a fact, I know that inside this line, we're gonna have space, operand space, and operand is gonna be either plus or multiplication. We only have two operands, so perhaps we can hard code it, but we don't really care about that yet. We care about parentheses, and there's gonna be nested parentheses in there. Perhaps what we can do is we can see an expression inside a parentheses as an individual expression. I'm sure folks that have written their own compilers, like you, Lars, yeah, or transpilers, have an intuitive way about approaching this problem, because this is what you need to do in a compiler as well. You get users, but then you have tokens that you can work with, I guess, don't you? But that's what the compiler does, I guess. The parser, it parses an expression with tokens, and then you can use the tokens to actually figure out. Yeah. So we can see anything beside a parentheses as an expression, and then if there's another parentheses inside an expression, then we go that one. We see that one as an individual expression. So we kind of have like a nested loop in there. While there's no parentheses in the expression, evaluate the expression and return. Kind of like that. How many nested expressions can we have? I see a one level here. Can it go two levels? One level. This one is one level. I guess only one level, but it doesn't say in the puzzle that it's one level deep. Can be more, no? And parentheses. Yeah, it doesn't say anything about how many nested parentheses we can encounter. So I can't assume it's going to be one. It can be more. So our code needs to account for that. Lexing, yeah, that's what it's called, lexing. Does the token. Either go left to right or build a tree with expressions. What's smarter probably depends on part two. Eric likes to add a twist. Yeah, for sure. Either go left to right, or so I'll suggest, or build a tree with the expressions. Yeah, I was thinking something like that. I wasn't thinking about a tree though. A tree is definitely a smart way to go about it. I'm not gonna go left to right. That's too much state to keep track of. It's like whenever you have like a large array or large whatever you need to parse, if you go token by token or element by element, then there's always some state you need to keep track of, because on each iteration you're only aware of that single token, but you need to know the context in which that token presents itself. So you need to know, is this a nested closing parentheses or outside parentheses? Is this like a left or right operator? And so on. And therefore that involves state, keeping track of a bunch of stuff. And I try to avoid that as much as possible, because state leads to bugs, usually. So I'm gonna try and perhaps use regex, but the regex is gonna be ugly. I'm not that very good at regex, where I can say grab me the parentheses and then another I mean, I could write a regex that grabs the parentheses, and then I could feed the new result into the same regex that will grab another parentheses. So that I can do until there's no more parentheses, and then evaluate that expression. Let's start. Can we start easy? Can we just start without parentheses? Nah, let's do the parentheses. I was wondering maybe I can just do the rest and then figure out the parentheses later. It's kind of like the blocking thing right now. Trying to figure it out. If I grab, let's, yeah, we can write a regex that grabs whatever is inside the outermost parentheses, and then we feed that into the regex again if we encounter parentheses, and then we get this expression, and then we can evaluate this expression. We're gonna get a result, and that's gonna return. So I'm sensing a recursive function. Yeah, recursive function. We're gonna use recursion, and then it's gonna return, and then it's gonna evaluate the remaining stuff until it returns a value. Yeah, that's kind of like what I'm thinking of. All right, so let's write this function in here. So what do we call these? Math expressions. Evaluate the expression on each line. Let's call them expressions. All right, and then we're gonna have a function that's gonna take do math. Express is gonna take an expression. Let's say evaluate expression. That's better than do math. And we're gonna call evaluate expression for each line. So we're gonna have expressions reduce accumulator expression. And we're gonna say accumulator plus evaluate expression 0, and that's gonna be our sum of expressions. Jumping ahead a little bit now, I'm already writing the end part of our today's puzzle, logging the answer. So sum of expressions, there we go. We have that in place, so we need to work in here. Why is oh, I made a typo. Okay. And inside here I have the line, and I'm gonna have to use a regex. So I'm gonna pull up my favorite regex debugger, 101.com, go JavaScript, and then let's put a test string in here. So we need to match everything inside the parentheses. So let's match capture group, and then starting with a literal parentheses up until it's going to be not at least 1. It's going to be, well, it doesn't really matter that much. I need a quantifier that's at least 1 or more. That's a plus. 1 or more of can be anything, and then we're gonna close have a closing parentheses, 1 or more of 0 more 0 1. Okay, and then we need a non-greedy modifier, because otherwise it's gonna go on greedy quantifier. Otherwise it's gonna go until the very last one. Last parentheses, which we don't need. What was the non-greedy modifier again? Something with question mark. I always forget it. Here, lazy quantifier. So that's so question mark, I guess. But we do a question mark at the plus here. All right. So we have our group. Maybe perhaps let's put this. Let's put the parentheses outside because we don't want to capture the parentheses. So we have our group in here. Yeah, that works. Let's see if it does the job with nested. So I see here, well, what's our nested? Well, that's interesting. Actually, it needs to be a greedy one, now that I think of. Yeah, it needs to go all the way until the last one, because otherwise it's going to stop here and then you have something like a weird non-closing parentheses, which we just had. Yeah, let's try another string, something more larger here. This looks pretty complicated. Okay, what do we get here? We get... oh, okay, so that doesn't work. Yeah, because it's gonna go all the way till the end. So I need to... It doesn't need to be a greedy one. It needs to be a lazy one. But... oh, I somehow need to keep track of... if it encountered an open parentheses, maybe there's a smarter way I can do this. Maybe I can just I just need to capture everything inside a group. Everything, yeah, okay, but I still need to be, So why it's failing, it's because it doesn't keep track of how many open parentheses it encountered. Therefore, it doesn't know whether this closing parenthesis is coming from the inner one or the outer one. And I need a regex to kind of like, that knows that. Let me think. I can use look aheads, but that's gonna definitely complicate things a little bit. Are the look aheads anywhere in here? No, they aren't. I thought they were in here. Let me think. I'm gonna Google this. Let's see if Google has a quick answer for us. Regex, capture, parentheses, regex match, parentheses, expression. Ooh, this person needs to split. That's smart. Perhaps I can do that too. Would split work in my case? What will split do? If I grab this string, perhaps there's something. If I can use split to kind of like have nested arrays for each nested parentheses, that'd be neat. Split this. Nope. So what do we get here? We get doesn't make much sense, does it? And if I split it by, I'm just trying stuff out here. We have another array. Wait, that's not gonna work. Map L dot split. What does this do? Interesting. What does this mean? Let's grab a easier. This one. Is there one without parentheses, perhaps? Well, here's a quick one. Let's try and make sense of it. So what does it return? Return 4 plus 2 times 7. 4 plus 2 times 7. Ooh, this is neat. 4 plus 2 is indeed in a parentheses, and then we need to evaluate this, and then the result of that with this, which are both inside a parentheses. Nice. Okay, let's try something else. Let's try 2 parentheses. So we have 3 times 7 plus 3. Awesome. And then whatever that result is, plus 7 times 5. And then we have a leading times here, so we need to evaluate this expression, which is inside. Ooh, this looks promising. All right, let's try nested parentheses now. We have one nested parentheses in here. So what do we have now? We have 9 times 6 plus 7 times 8 plus 6 times 3. We have all of this in here. And then we need to evaluate, and I kind of, oh, no. No, so with our logic, because these is inside an array, we're gonna evaluate this and then evaluate that and that, but we need to evaluate this first, which is kind of like an outside. Yeah, it's pretty hacky what I'm doing here. Just splitting with an open parentheses and then map split open. No, that doesn't work like that, unfortunately. But maybe, can we modify this in a way that will work? That will work. Let me log this out. Because what do we get first? We get first an array of elements splitted by this. So then we have 7 plus, and then we have another split. And then we have whatever that is, because those are closing. So we kind of need to keep track of, if we're gonna split by yeah, this is weird because it's just gonna split it, but it's not gonna nest the arrays how we want. Yeah, another solution would be, is like Lars suggested, to go one character by one and then keep this all in memory. That's something I could definitely do instead of complicating myself with regexes. It's a more intuitive tool. Let's try that. Let's try parsing it line by line. Yeah. Okay, so I'm gonna leave this in here in case we, well, it's just an empty function. In case we might need to come back to it, this doesn't work. Okay, let's try parsing it line by line. So I'm gonna have a, what I'm gonna do, I'm gonna keep track of some of, well, what are we doing as we go through each character? We kind of like need to keep track of results, expression results, and then we need to sum those up. So I might just do this, sum of expressions, and that's going to be 0. While, so while expressions, what I'm gonna do is I'm gonna pop an expression out of this array on every iteration. Array, and then this pop, modify the current array in place, the last element of array. No, I need the first one, so that's should be shift. Removes the first and returns the removed element. Changes the length of the array. Great. So we're gonna say have expression. and then we're gonna say expressions shift, and then while expression. So while that exists, because if we have an empty array, we try to shift from an empty array, we're gonna get an undefined. So then we are stopping the loop, which is good. So now we have our expression inside here, and we're gonna I guess we're gonna have to split it. Well, we'll have to loop. We're gonna have a string. We have a string here, so we have to loop through a string. Yeah, let's loop through a string. And how do you loop through a string? I could split it and then loop it, I guess. Yeah, let's do that. Expression, split, and then loop. But then I need to, I could use for each. For each, that's fine. For each token, I can call this token. Or I can say const tokens. I can kind of like take the same approach. Yeah, I'm gonna stick to imperative here, and I'm gonna say while let tokens shift tokens. Well, there's a token. All right, so we have a nested loop inside here for each token inside that string. And then we're gonna have either a digit, a space, a star, a plus, a closing, or an open parentheses. Those are all the possible tokens we can get. So we need to parse them. How can we be smart about this? Let's do the number. Const is number. Token. I could feed the token into the number constructor, and then if it's a number, it's going to parse it as a number. If it's something else, it's going to return not a number or none. If it's a plus as well, if it's a multiplication as well, if it's space. Oh, almost got a bug here. So JavaScript is weird. Apparently a space typecasted to number is 0. Is 0 anywhere? If token is equal to space or number equals to none, then it's not a number. So token does not equal to space and number does not equal to none. So if token does not equal to space and then number does not equal to none, number token, then we have a number. Okay, let's do that for what else do we need to parse? We need to parse the operands. Let's parse the operands. So is addition, token equals addition. I might refactor this in a little bit when it's more clear. When I'm gonna apply these variables, we're gonna have to work with them. I might refactor them, but for now I'm just gonna keep them like this. Is multiplication, is addition, and then the last thing we have is parentheses, is open, is close, and I think we need to distinguish between the two as well. Is open parentheses. Is that parenthesis? What's the singular of parentheses? Struggles of non-native speakers. Parentheses are punctuation marks. So what's the single parenthesis? A parenthesis, yeah, is open parenthesis, token equals open, and the same thing for is close, is closing parentheses. Okay, so we kind of have our parsing of tokens here, and now we're gonna need to say if it's a number. Okay, we first need to keep track of the parenthesis state. As soon as we encounter, oh, let me think. When we are inside an open parenthesis, we need another variable to keep track of that expression as we go through it before we add that variable inside to the sum of expressions. So let me think here. I'm thinking I could have a while loop again for each expression. But then it's gonna, maybe I can use a recursion here in a way. So okay, let's go one by one. So we get a digit. If it's number, then sum of expressions. If it's number, oh wait, okay. So first, if it's a number, then let's have another variable here that says evaluated expression, and that's going to be 0. And then here we're going to do sum of expressions plus equals evaluated expression. So we're going to work with evaluated expression here, and then while token yeah, I haven't done something like this before, so this is quite challenging for me. Well, if there's so it finds the first element 4, but it doesn't know what to do with it yet. So you kind of need to keep track of that. Can we say let left operand, and then that's going to be undefined, and then if is number, so we need to store this into the left operand, and then as we go we find multiplication, and then we need to store that into what is addition and multiplication. Those are operands, aren't they? Let's get the terminology right. Operands. Yeah, those are operands. And wait, what's here? No, that's an operator and operand. Oh, I see. Okay, left operand, let operator. So we kind of need to keep track of the operator as well. Let's try an easy expression, because is there any expression without parentheses? Oh, this one, great. So we have our left operand, we have our operator, and then we find another operand. Oh, it makes it much easier for us that we don't need to that multiplication and plus have the same operand precedence. That makes it much easier. So, and then we find another number. Okay, so we can say if is number and there isn't a left operand. Left operand is gonna be the number token. Maybe I can kind of like nest this if there's no left operand. Left operand is gonna be a number token, which I already written here. But if there is a left operand, that means the current number is the right operand, so we can evaluate the expression. We're gonna have an operator as well, so we can say evaluate expression if operator equals to plus, evaluate expression plus equals left operand plus, yeah, that's in parentheses, plus number token there. Otherwise, we know that operator is gonna be, let's be safe here and say if operator is equal to multiplication, and then we're gonna have another else, and we're gonna console error. We're gonna scream, oh no, no operator found. We should never get there though. Okay, and then we have evaluate expression plus equals left operand multiplied by the current one. So that's kind of like what I'm thinking of. And then here, if is addition, well, I don't need to know if it's addition or not, because I already do that here. So maybe I can say is const is operator token equals plus, or yeah, multiplication, or token equals plus. So then we can select this one, and then we can say if is operator, then we need to store that into the operator variable token, kind of like this. Does that make sense? And then what I need to do as well is when I've done if is operator, when I've done any of the addition, so let's say we are here now, the left operand now becomes whatever that was. So I guess I can say well, that's interesting. I need, so we are here, 5 plus 2, we add 2 to 5, and then we get 7, and then we add that to the evaluated expression. But then our left operand also needs to change as well. Left operand equals, let's not add it to the evaluated expression until we have reached the end. So let's just say left operand is going to be whatever is inside here, or whatever is inside there. Kind of like this, and then evaluate expression is going to be just at the end when we reach the end. Wall token. I'll have to figure that out later. But then on our so then we go on, and then we have multiplication. So we store this operator, we store multiplication to the current operator, and then we get a 4, and then we say if it's number and there's no left operand, these needs to disappear. If it's a number, if there's no left operand, then assign the number to the operand. If there is one, then we continue. So we have operator is multiplication, so we have 4, we do 4 times 7, because that's what left operand is, and we assign that to the we can basically do a shortcut here. Yep, that's the same. And then we go on, we assign it to the left, we get a multiplication again times 8. This should all follow through until we reach kind of the last one. So when we reach 4, we have a left operand of whatever the result is, and then there's no more token anymore. So we can like say left operand is the validated expression. So therefore left operand sum of expression is just kind of like this. We don't need a different variable. I think we can do this, yeah. That's good. Okay, and I think this should work. This should work for simple expressions. Let's give it a spin. Input 2. Now day 18. Oh, we have found a bug. No operator found. Interesting. Why didn't we find any operator? Operator equals to plus or operator. Oh, wait a second. Okay. If there is no left operand, okay, this needs to be an else. Then we can assume there is an operator. So then we can add this to the top. Yeah, that needs to be inside there. Let's try it again. Nope, did not fix it. If there's no left operand, otherwise there is a left operand. Wait, I just need to say let me think. You know what I'm gonna do? I was thinking of just continuing the loop if it's a space, because we can ignore spaces. But if it's a number, this is gonna be only gonna be valid if it's a number. And then if it's the operator, then if token is equal to plus, so then assign operator to token. That's good. So this only if it's a number. If there's no left operand, well, if there's no left operand, we assign the left operand, and then we can kind of continue because we're done with it. But if there is a left operand, so this still needs to be nested as far as if my logic is correct. Because if we have a left operand, and if operator is plus or that, otherwise do nothing. No, we should never do nothing though. because if we get a number and there's a left operand, we need to do something with that number. So if operator is plus, all right, let me just add a breakpoint and see what the debugger is giving us. So we have token is 5. Let me split this to the right. So we have token is 5. That's good. Left operand is 5. What is token now? 5? This number, that's true. This operator false. This number is true. There's no left operand, so we sign left operand. Why are we in here? I think something is amiss. Oh, I see what's amiss. While token shift, we need to do another shift here. That's silly. Token is equal to tokens shift. That's kind of like what we need to do, and we are wrong, the wrong loop. Yeah, and then here as well, we need to do expression shift. Expression is equal to shift. All right, this should do it. Let's run our program again. Okay, so we do get a oh no, operator not found. For that's weird. Let me run the program. So when do we get in here then? What's our left operand now? It's 5. What's our token? It's plus. Okay, 5 plus. We're at plus. Is number? How is token a number? Token is not equal to 0, and number token is not equal. Is no. How hard can it be to write this logic? Why is it spinning? It's invalid. Is this invalid? Well, plus is not equal to space. For that I know, so we can like don't need to debug that. Number plus is not equal to. Oh wait. That's weird. What's number plus? It's none. It's not equal to none. What? Oh wait, maybe none. What? Oh, JavaScript. JavaScript. Why is number is none? Number, if you typecast a plus to a number, you get none. That equals none. False. My God. Is number JavaScript. Silly JavaScript. Is none. Oh, there's a actually is none thing. Okay, so I guess I can do is none. I have to use a method instead of just equal. Okay, true. All right. Back to fighting JavaScript. Which is not equal to none. Okay. Let's run our program again. Great, 3,584, is that correct? 5 plus 2 is 7 times 4. Let's bring the calculator. 5 plus 2 times 4 times 8 times 4 times 4. Awesome, works. Great, we can move on. We can move on. Now we can deal with parentheses. Let's deal with parentheses. So this is gonna make things a little bit more complicated. Output the token in the error message. Yeah, it was super weird. Super weird. Okay, so parentheses. Parentheses. What is our logic gonna look like? Split to the no. Let's move this to the right here. Or we can keep this. Oh, I really like this one. It's kind of like a thriller, action, mystical vibe to it. So if is open parentheses. All right, so that's what we need to do. As soon as we encounter an open parentheses, let's add this to the bottom. If is open parent open. We need to keep a flat. So when we're gonna be here, we're gonna have our left operand be 5 and our operative plus, but we encounter an open parentheses. So we kind of need to halt everything in there. We need to kind of have another left operand. We need to start anew, which is where the recursion comes in place. Maybe I can create a function. Maybe I can create a function, evaluate expression, and put all of this inside that function. And when we, or let's just, okay, let's try and keep this with the imperative programming and the state. Okay, it's open parentheses. So we can have a flag that says if we are inside a parentheses or no. How can we? Because on our, so what do we need to know? On our next iteration, we're gonna have an 8. So we're gonna find a number, and then we don't have left operand here. So we could have, we can say, we can have another variable called left operand inside a parentheses. But I feel this should be nested in a let me think. Maybe I need to do something else entirely here. If it's an open parentheses, yeah, I talked about recursion earlier. It's, I know I can use recursion, it just doesn't come clearly in my head how that would work. When you write a recursive function, you always start with the stop condition. So the stop condition would be expression includes So our stop expression is going to be if our expression does not have any parentheses, then we kind of like reach the end. So if it doesn't have any parentheses, then we can evaluate it here. Otherwise, evaluate whatever is inside that expression parentheses. But yeah, we need to parse that as well, and I don't have the regex for it, so we need to do it by hand. So that's what I'm stuck right now. Is open parentheses. I don't have much experience doing stuff like this. Perhaps I should write my own compiler someday, or a transpiler, and practice. But I haven't solved this problem before, where you have an open parentheses, and then if it's open parentheses, we kind of need to know that we are inside the parentheses on the next iteration. Maybe we can, yeah, I'm thinking of another while loop in here. How about another while loop? If it's open parentheses, how about that? How about another while loop? If it's open parentheses, yeah, I'm gonna do another while loop, and then I could probably factor that later into a recursive function, but this comes more intuitively to me right now. I'll try and see how far I get with this approach, and if not, I'll definitely ask for some for help. Thanks, Lars. I'm sure you already know what should be done. I'm trying. I think I have something here that I wanna give it a spin. So if it's open parentheses, let left operand nested left operand nested left operand. Yeah, nested left operand. All right, so we have a nested left operand, and then we kind of copy paste. Copy paste. Great. We shift the token again. Nested token. Let nested token. And I already see where the function comes in handy, because then I need to copy paste this. Tokens, shift, nested token. Well, nested no, instead of all. Nested token. Let's see how far this gets me. Very ugly code, very not dry, but hopefully this will become, as I have it working, a working solution. It becomes clear what the recursive function should look like, because I cannot make that step in my head yet and go straight ahead by writing it. So if it's a number, then we don't have, okay, so then let's use the token here. And then I think we also have a nested operator. and we use that. Nested operator. Wait, is this a nested? Okay, damn. Yep, that's good. All right. So continuing with our logic here, somewhere, doesn't really matter here. We're at 8. So inside the nested loop, we have our 8 here, and then 8 is a number. Just figure out I need to copy this part as well. All right, so we have 8. 8 is a number. We don't have a nested left operand, so then we assign 8 to nested left operand. And then we go on and we grab space. Space, we ignore space, okay? And then we grab multiplication. And then multiplication is an operator, so we assign nested operator to multiplication, great. And then we go on to 3. 3 is a number. We do have a nested left operand this time. If nested operator is multiplication, so we go in here. So then we multiply the nested operand, great. And then we need to go on until we find a closed parentheses. So let's, oh, I see this needs to be outside. Great. And then, so if is, well, I guess I can just paste this in here. This definitely needs to be written in a recursive function. If it's closing parentheses, then we need to break out of this loop. Closing parentheses, but before we do that, we have evaluated that expression within the parentheses. So we assign the left operand, the outer left operand, to the, we can, oh wait, we need to know whether that, what the operator is. If the operator is plus, then left operand is going to be plus number nested left operand, otherwise it's going to be nested multiplication. Yep, we should never get in there. Good. And then we did that, and then we're gonna break. We're gonna break out of this loop, and then let's see, let's grab an input that has more stuff after. Yeah, so then we're gonna break out, and then we're gonna have plus more times. Yeah, so then we update the left operand in the outer loop, and then we have 6, and then stuff is goes on as normal. Oh, great! So now that we have that working for us, I think the next thing. Wait, let's program. Let's run it and see if it works. 342. So wait, calculator to the rescue. 4 times 6, 24. So we could just say 2 times 3 is 6, times 4 is 24, plus 9 is 33, plus 24 is 57 times 6. 342. Awesome. So that works. Our program works with one parentheses. Let's see if it works with, oh, does it work with maybe multiple parentheses? None. Okay, doesn't work. I wonder why. So we got our parentheses here. Oh, maybe because it's in the beginning. Maybe that's why. Yeah, maybe that's why. Okay, so if we have a parenthesis in the beginning, like this, what happens is inside of here, so if it's open parenthesis, yep, we grab 7. Nested token is going to be 7. It's a number. We don't have a nested left operand. We assign to it. Okay, next iteration, multiplication is not a number. It's an operator, nested operator. Good. We go on. And then we get 4. 4 is a number. We have a nested left operand. We do. So we go in here. And then it's multiplication, so we multiply it, and then we get a closing parentheses and left operand. Oh, I see what's going on. Maybe we should say left operand. If left operand, then do that. Otherwise, else, left operand just equals. And I think the nested is already in numbers, so we don't need to typecast that here. We don't need to typecast that in here. Then just say nested equals. Kind of like the same thing here. If there's a left operand, I'm gonna refactor later. This can be written in a line, but I don't want to bother. I want to make it work first. Otherwise, left operand just equals. Great. And why are we typecasting here? We copy these token. Oh, yeah, that makes sense. No, we copied these from, I don't know where anymore. Okay, let's see if it works. Still not a number. Left operand is, well, wait. If there's a left operand, so we should be in my closing parentheses. But wait, there's no operator outside. I see. So that would never happen. That would never happen. Let me reverse all of this. Because if there's an operator, we're gonna have a left operand as well. Yeah, that's where we left off. Okay, so we're gonna have a left operand as well, so we don't need to worry about that. But if there is no operator, else if, so I guess we're here, so this should happen. Then just say left operand is nested operator. Yeah, that's what we want to have. Okay, 28, 7 times 4, 28 works. Does it work with something more complicated like this? 92, 28 plus 4, 8 times 2 is 16. What's 4 times 16? 64 plus 28. 92, great. So that works now. We fixed it for this edge case. Yeah, I think we are good. We are good. We can go on with nested parentheses and fix our code for that. How about this one? Okay, so what's gonna happen is, do I already see a pattern here that I can extract to a recursive? I think it is going to become clear now that we're going to have nested stuff. So everything works fine until here. Then we're inside this loop, and then we have an open parentheses. So we kind of like copy that stuff inside of here. So I'm thinking if the function is everything in here. Well, no, wait. Where does it repeat? It repeats here. Well, yeah. So if the whole thing is a function, and I just, if it's open parentheses, return that function, and this is gonna return. I can try. Okay, let's try. So we have something working now. Let's try and refactor this into a function. Because if we do that, then we're gonna solve our nested parentheses case. So that's gonna be the solution. We don't need additional code. We just need to make this work. So everything inside here needs to be a function. So I think everything inside of here, because left operand operator and token repeats itself right here. Left operand operator token. This while loop is the same as this while loop. That's all the same. And then at the end, this is also the same. So the pattern that I'm seeing emerge here is that this, so this loop, no wait, this, because we had open parentheses. So as soon as we find an open parentheses, we run this code, and this code is the same as this code starting from here. It's the same starting from here. So without this is going to be outside of the function. All right. And then therefore, what do we call this? We pass. What do we pass to the function? We pass in a bunch of tokens. No, we pass in a token. It's going to be token by token. No. I think tokens. We pass in tokens. Not sure. If our function starts here, tokens. Yeah, we pass in tokens. Yeah. Okay. Tokens. Evaluate expression. We get tokens in here, and then we say our stop is going to be. No, we don't have a stop. Our stop is when we reach the kind of like closing parentheses. That's our stop. Tokens. So let's kind of like copy and paste stuff from here. So we're gonna have shift token, left operand operator good, and then we're gonna have a while loop. Let's kind of, I need to copy the while loop here, this part, but I need to not copy this part. No, not copy this part, and I need to get the last part. Great. Inside while loop, where are we? Here. Kind of like that. All right, so we have our token, left operand, and then operator good. Token goes inside here. While there's a token, yeah. And wait, if token is a closing parentheses, then we can return the result. Can we do that? If token is closing parentheses, we can return the result. If token equals closing parentheses, return left operand. That's going to be a stop. And therefore, we can get rid of this inside here. If token is open parentheses, if is open parentheses, Yeah. Then we need to call that function. So we recurse, and this is gonna be with our tokens, I guess, with our tokens, and then we are going to have to we're going to have to assign this to our left operand, kind of like we did here, but we need to have this logic here. So going back is open parentheses, evaluate expression. Kind of like this. I can refactor this in a bit, but I just want to see if it works. And then if is open parentheses, then we're gonna have our recursion in there. And then we go on. Shall we give it a spin? Shall we give it a spin? Evaluate expression. What we need to do first is we need to let's comment all of this out. Oh wait, something else that we're doing here is where yeah, so let's comment all of this out up until here, and then inside there we're gonna do token split, which is good, and then we do sum of expressions is gonna be, let's comment this one out as well. Sum of expressions is gonna be plus equals to evaluate expression tokens. Yeah. All right, I'm curious to see if it works. Nah, it doesn't. Did we change our input? Input expressions. So we kind of like shift expression, go inside here, expression split tokens, pass in the tokens, we assign the result there, we shift again, good, tokens, evaluate expression, goes inside here, tokens, shift the token, yeah, you get the token, left operand. Left operand, we assign it here. There must be a bug somewhere. Must be a bug. Let me see. Where do I add breaking points? I bugged out our recursion. Token is left operand. If token is equal to closing parentheses, then return. That's our stop condition. All right, so then while there's a token, do we have another return? Oh yes, we need a return as well. I got it. So let me think. This is gonna return left operand. Is this what I'm looking for? Perhaps. We do get a number now. Let's see. We already evaluate this. This was 3,584. That's correct. And I think I forgot, but what does this return? 9 plus 7, 16. 9 times 3, 27, plus 4, 31, times 3 is 93, plus 16, 93 plus 16. Yeah, 109. Awesome. So that works. Let's try double parentheses. 92. 7 times 4, or it's that was 92, I think. Was it? Yeah, 92. Awesome. And it should now work off the bat with nested parentheses. So let's grab one that's not too large to here. This one looks good. If this works, then we might have our answer for the first part. Let's go in and see 3 plus 2 is 5 plus 5 is 10 plus 9 19 times 3. 19 times 3. 57 times 4. And plus 5. Oh yes, it's looking good. It's looking good. Was this something that you wanted to? Was this the recursive function you wanted to suggest, Lars? Something that looks like this, or perhaps something else smarter. This seems good. I'm gonna run it with our original input and see if we get something that looks like a possible solution. A huge number here. I wonder if that's maybe works. Too low. It's already a big number. Okay. So I'm guessing that there's an edge case which isn't working for our recursive function. We tested with nested parentheses. How about something like this? How about, wait, we have some example inputs here to work with. Yeah, let's test all the example inputs. Maybe one of them, that's 26, so that one works. This is where it's handy to write tests. Some folks write tests while they do advent of code. Can they just run this program and they just, before they try the answer, they run the test, and if the test passes for all the example inputs, then you know it's working. Well, what am I doing here? There. 12, that's correct too. I think this one might be incorrect for us. 14904. Yeah, this one's incorrect. All right, so we have something that we can debug. So where is it going wrong? Let's add some breakpoints. I guess we can get rid of these. We're not using them. Okay, I'm gonna add a breakpoint. Where am I gonna add a breakpoint? Let me think. Maybe I can already figure out what's wrong by just looking at the code. It's gonna go inside that, is open parentheses, is gonna evaluate that one. If it encounters a closing parentheses, it returns. So here, it should return here because we're already inside a nested one, so it should return here. Left operand. So this one should return, and then we assign it to the left operand, and then we should go on, and then we have another open parentheses. I should go inside there. It's going the right direction. I have an assumption. I have a feeling here that you already see what's going wrong and just leaving me here suffer. And then we go on with I think somewhere here, so something's amiss here. Return left operand as we go through the loop. You know what's weird? This is weird. Evaluate express. This is weird. This shouldn't be here. It should be somewhere here. Yes, that was a bug. Yeah, that looked really weird up there. So I guess I'm gonna have const is closing parentheses. Yep, token triple equals, and I'm gonna say that. Awesome. Let's give it a spin with our own input. We're gonna get a new answer. We're gonna try that new answer, and hopefully, oh, this is a larger answer, so that looks very promising. Oh yeah, 1 gold star. We did it. 1.5 hour in. Awesome. Continue to part 2. Woohoo! Yeah, that was a bug. Awesome. Part 2. Let's go on. You managed to answer the child's questions, and they finished part 1 of their homework, but get stuck when they reach the next section, advanced math. Okay, so here's where our twist is. In today's puzzle, we're gonna have some slightly more difficult rules for our math. Advanced. Now, addition and multiplication have different precedence. Oh no, that's what I feared. Oh, that's what I feared. Okay, but they're not the ones you're familiar with. Oh, math is not math. Instead, addition is evaluated before multiplication. Okay, for example, the steps to evaluate the expression are now as follows. Plus comes first, and then multiplication second. Here are the other examples from above. Still becomes, all right, so what do you get if you add up the results of evaluating the homework problems using these new rules? Okay, so let's try and think now. Our approach is still going token by token. So I think by using a recursive function, we do make our lives a little bit easier for the second part. Maybe not, maybe it doesn't matter at all. I'm just gonna get rid of all this stuff here, by the way. So, yeah. Yep. All right, so let's go into part 2. And we're gonna need to change our function to take precedence of plus and multiplication into account. All right, so we have, what's gonna happen now? We have left operand, we have a token is number. I guess let's start easy. Let's start with this one. 3 plus 2 times, well, this not easy. Well, let's shift this like this. Ooh, but wait, we can kind of like say, if we find addition, we can consider that there's parentheses around those operands. I'm thinking, can I be smart and before I pass the tokens in to this function, can I just add parentheses around, can I modify the expression? So instead of passing this, I pass in this. And then we don't need to modify our function, it's just gonna work because parentheses get precedence. Maybe that's something I can be, maybe that's really smart. So I'll need to, I'll need to go through each input. So maybe I can say expressions, okay, new expressions. New expressions. Maybe I can go through each expression. I can map the expressions. Does that sound like something? For me, it sounds a little bit really smart thing to do actually. Then I avoid changing all this logic with precedent stuff. Let's see if I can pull this off. So for example, in this case, I need to add parentheses around the first plus around, yeah, and then another set around. So I need to add a set of parentheses for each plus I encounter. So there's gonna be parentheses, there's gonna be parentheses. I kind of need to spread outwards. So I'm gonna have a loop that spreads outwards. We have our expression here. Man, I'm sure if I would be good at writing regexes, I could do this with a regex. But maybe what I can do is, all right, so we have our expression in there, it's a string. I don't have to split it. I could split it. I could use a recursive function in here too that expands somehow. Let's see how I'm gonna do this. A string, we have a string, then when it finds a plus, it needs to go outside of that plus until it finds a digit of both sides. So for example, if this would be a plus, it needs to go, but it doesn't need to stop here. It needs to stop because we're in parentheses, it needs to stop outside of these parentheses. Ooh, that makes it more complicated. Yeah, that's a little bit tricky. I hope this approach would be pretty straightforward, but it's not easy to modify the expression to add parentheses. The logic for it is going to be a little bit tricky too, because you kind of need to grab the left operand and right operand, and the left operand can be itself within parentheses. It can be a number, in which case it's easy, you found the left operand. But if it's parentheses, then whatever is inside that whole thing is the left operand. But that's not too hard to program. All right, thinking a bit here how I'm gonna write this. So expression, this is gonna be the entire expression, and then we need to, let's grab this one for example, easy one. We need to go, we need to loop through, so maybe we split it and then we loop it and we find the plus, and then when you find the plus, split, and then when you find the plus, can we, I'm gonna make myself easier. How can I improve this? Can I split? Let's have the playground here. Playground, yep. What if I have right, I don't know what it does. Split. What if I split by plus? If I split by plus, ooh, no, I was a bit too enthusiastic. But perhaps, so if I split by a plus, then I get the left and right operands. But is there a split that does only the first? Because what I need to do is I need to split this by a plus, and then I need to go on and then split this by a plus, and then I need to go on and split this by a plus, and then I need to go on and split the... No, not really. I need to go from the inside out. Yeah, I need to go from the inside out. So from the parentheses. I think our split approach is not gonna work again. It's not gonna work. No, because no, split doesn't have a notion of inside and outside. What do you think, Lars? What would your guess be? Would your guess be try and make it work with this approach? So try and kind of like modify the expression and add parentheses so then it just works what we have here? Or should we just go into this function and account for the precedent, for the fact that the plus does not have precedence, or it has precedence over multiplication? How is that gonna look like? I cannot do precedence properly. Yeah, me either. Me either. So the problem is with this approach is that there's more state to think of. Ooh, but maybe, so here, if it finds an open parentheses, we kind of like go into, we call the recursive function because that's an individual expression. Can we perhaps do the same thing for plus? If operator is plus, no, because then it needs to go back, left operand. But maybe some different rules. Okay, if it's operator, so something here. If it's operator token. So let's take this for example. Yeah, 9 times 6 is gonna work. This is also gonna work. This is also gonna work. It's gonna fail when plus is after a multiple. Here it's gonna fail because it's just gonna go one by one, and what we needed to do is we needed to execute this first and this first. Okay, so it's gonna go in here, it's gonna find plus, it's gonna work all fine, but when it finds a multiple, when it finds a plus, okay, so when it finds a plus, this multiple shouldn't be executed. So that's where the problem is. We need to kind of like loop ahead, because here, if it's a number, if it's left operand, I need to loop ahead, because here, if it's a 9 and left operand is going to be multiple 9, I shouldn't add it, so this shouldn't happen because there's a plus after this 9 that this 9 belongs to. So maybe I can add another loop that's gonna look after what happens after this number. It's gonna do a look ahead. Not very efficient. Or kind of keep track of or if it's a multiple, do not add it. Do not add it until maybe I do some kind of pattern matching. Find the plus, replace it with the result. Some kind of pattern matching. Find the plus, replace it with the result. You mean like find a plus and replace it with the result? Yeah, the problem is that on the left hand side of the plus there can be a different expression. So I could, yeah. Type. What if I'm wondering, is there a split? So if I can just go, if I can just go through the expression, and as soon as I find the plus, I grab the left and right operands, and then pass those into the recursive function. It's going to be a very different function. Yeah, this recursive function is not that smart, I just found out. Because a really smart recursive function that would have worked for both parts 1 and 2 would be a function that kind of like works from the inside out. So without this while loop, I'm thinking, can we refactor this while loop? Into something that's recursive. So can I remove this while loop and then have it? Yeah, because it needs to work from the inside out. So it needs to kind of like token. Because if I extract this part out, evaluate expression, maybe what I can do is, so I keep track of the left operand. No, maybe I can still use this. Wait, let me think. Is number, so we go in, where were we? Here. So what's gonna happen? It's gonna be, we have token is number, there's no left operand, assign the left operand to the number, and then go on. So then we have a plus, and so plus is operator, we have an R operator. Go to the next, we have a 2, and then we add it. But if operator is multiple, we only need to do the if operator is multiple, this is going to be our left operand. If operator is multiple, we kind of need to go on until we find a plus operator. So the something that loops through all the elements and then first evaluates the I think parentheses still get precedence over plus, but first evaluates the pluses and then does another loop and then evaluates the results of those, kind of like what we see here visually represented. So what I first need to do is I first need to loop through these and only evaluate the pluses, and then as soon as all the pluses are evaluated, we then evaluate the remaining stuff, which is going to be this, and then we get a number. That's pattern matching. So it will be a regex of if we have a digit and then a plus and then another digit, should be safe to calculate, can be replaced with etc. Yeah, so maybe I can use this pattern matching solution into what I just proposed. So we have our expression here, and we're gonna use that match expression. Expression dev docs. What's expression? It's a string. So let's see strings match. Do I use match? String match. And we need a regex, and then it's gonna match or against the regular expression and returns a return value, an array. Yeah, so maybe I can use a match, and then I'm gonna grab the left hand and right hand side, and then those are gonna be individual expressions that I then need to pass on. So maybe I can already do it here. So I'm going to get rid of this because we're not going to use the parentheses approach anymore, like modifying the expression with parentheses. So we're not going to use that. I am just gonna copy everything what we have, not everything. Actually, not everything. Let me just copy this function, and I can call this well, yeah, evaluate expression part 2, for lack of better naming. And then so we get our tokens in here. Wait a second. Let me copy this to the bottom as well. That's a part 2, sum of expressions. We still need that. We shift an expression. We have our expression here. We split it. We don't need to split it. We don't need to split it. Evaluate expression is gonna be expression sum. All right. So in here we're not gonna get token. We gotta get expression. And then let's do our pattern matching here. Expression match. And then we're gonna say we have our plus in there. And then anything that's on the left side, it can be also parentheses. So I'm just gonna say anything. Don't really care. More than one. capture that, and capture the left hand side as well. And yeah, let me just write this in the regex debugger here so then I can see what's happening. So we have full match. Here we have group 1. Oh, it's going into the last plus. Okay, so we don't need to. We need to modify regex a little bit. It needs to grab the left-hand side and right-hand side, and that's just gonna be 1 digit. And if it's a parentheses, keep going on. So kind of like, yeah, what you suggested, Lars. 1 digit on this side and 1 digit on the other side. Or like the parentheses stuff. So here it does what it should do there. However, wait, this one is wrong. Can I make this bigger? Oh, it's okay. Continued. Okay, that's just the same line. So it kind of works, doesn't it? Yeah, it works. So then what I do is I need to evaluate these expressions and replace them with the result, and then I get a new iteration, and then I pass. There's a recursive pattern here. And I need to do this for as long as I get, because let's say this is evaluated. So let's say this becomes 10, on the next attempt it becomes a 12. So then we grab, oh wait, so I see already bug. It can be a 2-digit number as well. Alright, so that's going to be evaluated yet another time. It's going to be 15. Okay, and then we don't have any matches anymore, so we need to keep going until, oh wait, we do have a match here though. I'm thinking, can we modify our regex to also? No, we need to grab this match as well, I think, because then or continue until we don't find any matches, and then pass this to whatever our function is up top here, because then we're fine with those rules, aren't we? Aren't we? How is this gonna work for this example? So this is gonna be 5, and this is gonna be 5 plus 9, and this is gonna be 14. So then on our next attempt, we're gonna have 19. So it's gonna evaluate all the possible pluses until it can't anymore because there's parentheses. But I wonder how does it work with if we have something like I'm not sure. Maybe there isn't an edge case, because I'm thinking there's an edge case that we are missing here. Yeah, what if, for example, you get something like wait, let's go input. So this is gonna work. Yeah, what if you get something like this? What's gonna happen then? If you have this, then we're gonna say this is 11. So then this is just 11 when we find a digit with no operands, and then we'll multiply it by 4. So then we're gonna have 44, and that's just that. And then, well, in this case it's easy because those are enclosed in parentheses. So we can evaluate the brackets, and then that's just gonna work. So that's good. I'm thinking, what if you have, let's go to another input. Yeah, what do you have this? This one. It's gonna be 2 times 3 plus 20. And then we get a match. And then we need to evaluate this before we evaluate that. So as we evaluate parentheses, we can find another matches of this expression. So that's something we need to take into account. That's something we need to take into account, because if we evaluate all the pluses until we don't get any matches anymore, then we need to keep going on, but then we need to keep to be mindful that when we evaluate expressions, we might get new matches. Good, so that makes sense a little bit. Let's see how that looks in program though. So we have our matches, I think. We get a bunch of matches. Maybe remove the global. So I need to replace 3 plus 1, 3 plus 9 with something else. Okay. All right, so string match. It's gonna return an array. We're not using the G flag. Only the first complete match and its related caption groups. So how does that look like? Because match, I always trip up with match because it returns an array, and I have no idea which element represents what in that array. Why is, oh my god, Prettier is messing with me. Why are you messing with me, Prettier? Well, I can do like this. And copy this. Match. So what do we get now? Oh. First. What? Let me get rid of everything. So what is wrong here? Oh wait. Okay. Right. So we get an array and we get the first match. So the match is gonna be, also we get the index. Can I use capturing group? Capturing group. It's easier. Well, named capturing groups, named capturing JavaScript. How does it work? What's the syntax? This is the syntax. Okay, so it's gonna be parentheses, colon, yep, another parentheses. No, wait here. And then we name this, wait, and then what? And then what? I don't get it. Where's the name? Maybe there was a link there. No. Oh, damn it. Named capturing groups. Okay, Mozilla to rescue. So what are I doing here? What is this? Groups and ranges, regular group sessions. I need named capturing groups. How hard can it be? Duality has good stuff as well. All right, yeah, okay. Match. No? Oh wait, maybe without the colon. Groups. Okay, this works, I guess. Yeah, it's gonna be into groups, and then we get all the groups. Yeah, okay. Groups match. Okay, so let's copy this. And then we can assign it here. Groups. No, actually I prefer to do like this. Groups. Match. No. Groups. Match. Yeah. We have our match in there. Or we can do like this. Match. Yep. Great. And if we don't have a match, let's say we don't have a match, whatever it is. What? No? Yeah, I always report that. So it's no. The whole thing doesn't exist. So expression match. Okay, then I need to do a question mark here as well. In case you didn't know, question mark dot is kind of like, okay, if it does exist, then get the groups. Conditional, I don't know what the official name is called, but it's a new feature in JavaScript. It's awesome. Okay, so we get our match here. And then when we have our match, we need to evaluate that. So we need to evaluate that. I'm thinking here, if there's a match, then we need to evaluate that. Then we, no wait, there's a match. Okay, let's see. 5 plus 4. There's a match. It's 5 plus 4. We need to evaluate 5 plus 4. How about, yeah, how about this? How about if there's, oh wait. How about if there's there is a match, then if there's no match, we can return expression. No, we need to return if it's evaluation. No, this ain't gonna work. If there's a match, 5 plus 4, we need to evaluate that one. Okay, so evaluate match. Okay, we can say evaluate expression part 2. Evaluate expression. We can pass it in here, I guess. And then can we return that? Well, yes, but we don't. We don't return. We return in this case that expression, but we need to substitute that with the expression. So we need to. Okay. So let's. I think we get more stuff here. We get the index. So index 9 means what? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is where we start, and then the length of that. Okay, good. So what we need to do is we need to replace 3 plus 9 with whatever this returns. So we need to say let's replace it. I think with splice we can remove stuff. Splice. Just take the text and pass it to part 1, the match text. Oh, is that smart? Match text. Yeah. All right. Yeah, that'll work. That will work, I guess. I was planning to copy that here, but it's gonna work. It needs to, I can pass it to 1, and then whatever the result is, I need to modify the current expression. So that's gonna be slice. I need to, oh, this is string stuff. I don't, oh yeah, string stuff. Wait, I can do replace, no? Replace. Expression, replace, match with this, whatever is in here. But then string. Because we're gonna get a number there. Okay, I think so. That's gonna replace our expression, and then the result we need to pass it into itself. Kind of like this. It's hard to read. Const new expression. New expression. There we go. Okay, replace match. All right, so if there's a match, continue, and then pass it in again, and then if there's another match, do the same thing, pass it again until there's no match, and then we're here. And then if there's no match, just pass it like this, I guess. So they just pass the current expression to what we have in part 1. And what's gonna happen then? What's gonna happen then? Because if we pass, because we can have other pluses as well, so we need to be mindful of that. For example, this one. So on our first iteration, we're not gonna find a match. So it's gonna evaluate the expression, but then there's a problem. You know, actually the evaluate expression from part 1 works, except that let me think. So it's gonna pass in the entire expression to part 1, and then yeah, we're gonna get the wrong answer. We need to part 1 is gonna take over our computation, and we don't need to do that. We need to do just one round. Let me think. Need more rules. Yeah. Because we don't have a match, and then we're gonna pass we do have a match though. Here there's a plus. Need more, because there's a, let me see, we do find a plus here. So can we somehow pass this into the first part, and then get a number, and then we have a match, and then pass that into the first. Yeah, maybe we need to, what if we change our regular expression to also grab parentheses stuff. So also return something. Okay, so also return here, return a match here. Return a match here, and then you have a match. But wait a second, that's not gonna work, because we know here for a fact that our left and right hand side are can be evaluated. Well, that the whole thing can be evaluated. Yeah. Let's have another regex. Yep. So let's rename this to not match, but a what do we rename this to? It's not gonna be match. It's gonna be it's going to be an expression that can be evaluated. It's going to be a plus expression that can be evaluated. Addition expression. Addition expression. And then this one is to, oh, let's, yeah. Okay, that's an addition, not addiction, addition expression. And then we're gonna have another one that says there's gonna be this. So let's try and match that. Or space plus parentheses is gonna, it needs to start, yeah, it needs to start with an open parentheses, I guess. And then it needs to go on, ooh, this is tricky, it needs to go on until actually until the end. Yeah, it starts with open until the end. till the end, or just capture anything. Wait a second. If there's an additional expression, then that. Otherwise, we can try. What we can also try and do, we can split the string with a plus. What if we try and do this? Expression split plus like this. Then we're gonna have a left and a hand side, and then our right hand side is gonna be something that we can work with. So we have two sides now, and we only evaluate the side that starts with parentheses. Oh wait, but split is eager. I just need the first split. I don't need to split all the pluses. How do I split something? I first stop at first split. That's weird, interesting. Split single. Maybe I can still use regex. Suggestion from Lars. Also safe to evaluate. So what can I try here? So open parentheses. Ooh, that might be it. That might be it. Let's wait. I can just copy paste that and try and understand it. So what does this do? This match the open parentheses literally, and then comma. I don't think we need a space in here. And then digits. And then another space, and then how many times of those? Another space plus space, or should the spaces be there? Let's see. So what is this trying to do? This is trying to capture this, right? That's what we're trying to do here. Where's the, maybe I need to add a plus in here. So there's a plus here. No, that's a quantifier. That's also a quantifier. There's no plus here. Or this just matches the right hand side. What does this do, Lars? Getting close to 2.5 hour mark, so hinting a bit more. Yeah, thanks, appreciate it. Yeah, too many spaces in my stuff. Okay. So no spaces. Open parentheses, you remove the first space and then keep the second space, remove the third space. And remove the last space. So it does, what does it do? It finds the parentheses enclosing only multiple operators. Oh, I see, so matches the character. All right, so that's what it does. So do we have a match anywhere here? No, this should be a match. Let's see. Literally digit and then a space. Oh wait, okay, so this here needs to be a space. All right, so it matches that one. I think. No, it doesn't. So there should be a space between the operand. Yeah, there we go. All right, so it matches multiplication. Literally, there's a space around it, and then we capture the digits. What do we capture? We capture anything that follows that multiple times. Well, this is really interesting how this capture actually captures the whole thing. I don't think I understand it, but it is what it does. It does do. So now we have. Let me get rid of this one a little bit for now. So this captures all of those. Okay. and then we can. So you're suggesting kind of like pass these on to that function. And how about this? Oh, it doesn't match that one. Because what if we have, yeah, so what if we have like times 12? Is this what the regex is trying to do? Yeah, so we need to fix the regex then, if we're gonna go that approach, to also have it match this case. So let me try and comprehend the regex and I can fix it. Start with the parentheses and end with the parentheses. That's good. Inside there's gonna be a digit of how many long and a space, and then it's gonna be a multiplier, and then we're gonna have a digit, how many long, and this can multiply. Yes, that should work. Maybe the space needs to be inside here. All right, yeah. Okay, so that fixes it. I guess we can have however many, whatever. Okay. And what if we have a plus? Yeah, we're safe. All right, and pass this to all right, let me copy this over here. Just a second, something is off. Literal. No, wait. Why is my expression off? Oh, because I'll put it in inside there. Yeah. Right, this works. So now we are doing that. Let's let me get just. So what are we doing here? We are grabbing this. We are passing that to the first part, and then we're evaluating it and replacing it. And then we are passing the result to our recursive function here. And so then we're gonna get a match on this 3 plus 20 is gonna go in here. We pass it in again, so that's gonna be evaluated. And then we won't get a match for either of those, and then we just return the whatever. Okay, let's get rid of all of this. And then let's evaluate expression part 2. I guess let's run the program, see what happens. All right, I get name collisions. Let me fix that really quickly. Name collisions. Thanks for helping so far, Lars. Appreciate it. We're making progress here. That's really nice. Let me just wrap this as well here. All right. Then no more name collisions anymore. That's good. Let's run and see what happens. 0. Wait, we're should be parsing this individually. Because we're modifying the array in place. So therefore, first part's gonna mess up with the second part, but not anymore. All right, so we are going in there. We get a match, maximum call stack size. What are we doing wrong? That's interesting. So let's add a breakpoint here. So expression is, oh wait, let's work with our example input here. Still call stack exceeded, okay. So our expression is that's correct. Our addition expression, we don't have one. Our multiplication expression is going to be that, and then our new expression is what's going on? Oh wait, we evaluate that expression. Let's make this a little bit more readable. Const evaluated expression. We pass that into this here. Okay. So therefore we can replace this. So then we have, then we're gonna get a number, I guess. Let's run again. I'll make this a little bit more to the right to create more space. All right, go into here, multiplication expression, good. Breakpoint there. Wait a second. Addition is undefined, that's correct. And then this one is defined. What is it not? So perhaps it goes into here. Yeah. Evaluate. Oh wait, that function doesn't exist. I get it. I need this stuff. I'm gonna refactor later. Evaluate expression part 1. So we're calling part 1, where are we calling it? Here and there. Okay. How about now? Token shift is not a function. Somewhere a line 72. 72 token shift tokens. I see. I need to split this expression into tokens. It's a little bit messy right now. There. Okay. Does it work? Next bug, match is not a function, expression match is not a function. So therefore expression is undefined. Let's yeah, there's some just edge cases. Yeah, so I agree. I think so too. Let's add breaking points here before we go inside, and then let's add breaking points here as well before we return. Okay, so addition expression, there's none. Multiplication, there is. Okay, so we go inside. What just happened? What just happened? So I'm calling expression part 1. It doesn't even evaluate this. It splits into a string. What's the evaluated expression? And then expression replace with that. Yeah. So evaluate expression part 1. So it goes into here, and there's a bunch of stuff in here. Evaluate. Oh, I see. Yeah, that's what happens when you copy paste stuff. Right. Back to maximum call stack size. Fun stuff. Multiplication expression. So what? Right. Let's run again. So no, we go in here. We go. All right. Now we have a new expression. Wait, we have our evaluated. That's 10. So 4 times 5 is 20. That's good. So our new expression is 2 times 3 plus 20. That's looking good. And we pass the new expression into our current function. So then we have, go inside here, addition expression 3 plus 20. That's correct. So we go inside here, and now our evaluated expression is 3 plus 20 is 23. Not 5. Addition expression 3 plus 2, 20. 3 plus 20. And then we split. Oh, wait a second. Oh, Jesus. Oh, yeah. This is the first time we have double digits. So our answer for the first part isn't correct at all, because it assumes that all digits are all numbers are single digits. But this is the first time we have double digits numbers. So our solution for the first part doesn't work anymore. Yeah, so 3 plus 20 tokens. Token is number, yeah. But it needs to know whether the next token is a number. So what do we do here? Is number, if is number, and and if is number. How can I quickly hack this? Yeah, all the logic is in there. So if is number and tokens. I don't have a this number. Okay, so let's add some logic in here. So next token is a number. So we got our next token in here. Let's say, let's rename this to next token. So our next token is in here, and then we can like copy paste this stuff in here, and we can say that, and then we can say is next token a number, or just next token is number. Yeah, next token is number. So if it's a number, and if next token is a number, is not a number, and next token is not a number, then do this. Otherwise, if so if it is a number, if next token is a number, then we need to just go on, and then we go to the next one, and then if then we go inside. All right, so then we go inside in here, and then we need to figure out what the number is. So while, oh no, we discarded that number. That's not good. We're losing that number. So how about this? How about this? If is number, not closing parentheses. If is number and next token is number, then we need to keep track of the number, kind of like here. Let number equals token. All right, and that's going to be number string. That's going to be a number string, and then number string we add it, and therefore we don't need to typecast it. All right, so if the current one is a number and the next token is also a number, add the current, I'm gonna say continue here. Maybe I can skip the continue. Because it's not going to go anywhere here, is it? If it's number next token, no, it's kind of like so it's kind of like else, if else, and put this inside here. All right, so if the current one is a number, next token is a number, then keep track of the number. And if it's not, then we're here, and then instead of using token, yeah, so we have our number string there. It's gonna be token, and then if next token is not a number, then the number is number string, otherwise number string, because that's going to be an empty string, so then we can cast, otherwise it's going to be number token. And then we can use this number in here, and we don't need to typecast it anymore. This is kind of like what I'm thinking of, and I think there's a bug though. I think there's a bug in that. So let's say it finds a 2, next one is a 0. 2 is number, 0 is number, so just append to it. And then, alright, and then we need to kind of like, as soon as we do something with the number, we need to empty that string. So we empty that string. We empty that string there. Yeah. We assign this to an empty string. Yeah. This could be written much clearer. This is dirty programming territory. Okay, kind of like this. Okay, this will work. God. Let's debug. So yep, 4 times 5. Evaluated expression is not a number. Just making sure. Yeah, so 2 is gonna add 2, and then next token is number, we get to 0. Next token is not a number, 0. Oh, wait a second, I see. Then we need to add the current number. Therefore, number string plus token. Kind of like this. Still not there, but I think we fixed that bug. So it's going to be 2 plus 0 is going to be 20, and then typecast that into a number. All right, so that's fixed. Let's add a breakpoint. Where do we add a breakpoint? Let's remove these ones and this one, and let's add a breakpoint before it goes in here, and then before it goes into left operand, and here as well. Okay, run debug. So what are we working with here? Tokens, 4 times 5. All right, so token is open parentheses, we don't care about that. What is happening? Oh wait, I see. Oh, silly me. If else, if is number, and next token is not a number. Yeah, because it can be something else as well. Okay, stop, run again. Well, all right, so before it goes in here and then there. Okay, cool. Let's run again. So our current token is open parentheses. It should not go in either of those. Our current token is 4. 4 is a number, so it should go. Next token is number false. Next token is. Oh wait. Oh wait, no, that's true. 4. Wait, what's tokens? 4 times 5. Oh yeah, that works well. Okay. So we go in there. We go through those. We need to get to the expression where we get 3 plus 20. Okay, so last iteration, I guess. Evaluate expression 20. Okay, next one. Tokens 3 plus 20. Here we are. This is what we were trying to debug. Tokens 3. Yeah, 3 plus 20. Alright, so token is number. Next token is space, therefore true. This is false. We go inside there. Yep. And then we if there's no left operand, yeah, assign left operand. So now left operand is 3. That's good. Our token is space. We ignore space. Token is plus. We do something with plus. Token is space again. Jesus. 2. Okay, so token is 2. Next number. Next token is 0. Yes. So we append this. We should go in there. Next token is number, so we should not go in there. Okay, so our number string is 2 now. And is number true? Next token number is false. Good. So we go in here, and then what's our number now? Should be 20. 20. Okay, that looks good. So we should be adding, we should be going in here. Operator is plus, so we go in there. Left operand and then number is 20. We should be adding this to each other. And then we are emptying the number string. So let's add a breakpoint here. So left operand is now 23. We empty the number string there. And then return. What's something bad happened. Something bad happened because we left off here and then tiny and then closing. Then we return that here and then evaluate expression. Let me just add another. I think we fixed that bug. I think something else is going on wrong now. So evaluate expression is 20. And then the next round, it's quitting on me. Four times 5 is 20. 20. Replace that with 20, and then we call the new expression in here, and then so on our next iteration, oh, we have our addition in there. Okay, cool. So let's add a breakpoint. Let's add a breakpoint here. All right, so our validated expression is 23. That's good. 3 plus 20, our addition expression is 3 plus 20, evaluate is 23. So we replace 3 plus 20 with 23. So we should get a new expression, should be 2 times 23. 2 times 23. And then we pass that in here. And then we're not gonna get a match for addition. We're not gonna get a match for, so let's add a breakpoint. So no match for addition, no match for multiplication. Therefore we use the part 1. All right. This should work. It doesn't because I'm not splitting it. This should work. Okay, so we get 46. This is 4 times 5, 20 plus 3, 23 times 2, 46. Good. So let's try more inputs here. Let's try, I don't know. Let's try this. but we already did that. Let's try nested parentheses. 201. Whew. So this is not math. So what do we do here? 6 plus 6 is 12. 6 plus 9 is 15. 12 times 15. 12 times 15. 180. So then 4 plus 2 is 6, plus 180 is 186, plus 8. 186 plus 8. 194 plus 7. 201. Yes, works. Shall we just try it with our own input? See what happens? Yeah, thanks for sticking around, Lars. Appreciate it. For all the help as well. We might have our answer now in just 3 hours. Too low. Okay, so we have a bug. We can figure out where the bug is by trying a few different inputs. So wait, second input. All right. So 51. This becomes 46. That's correct. This is 1445. Yep. Still works. 669,060 still works for that as well. I think this one is the one that gives us a bug. Ooh, still works. 23340. That's interesting. Maybe did I modify my input somehow? We get good for all the cases. So what do we do here? I'm just gonna grab the input again, just to make sure I didn't accidentally modify it. All right. So what do we do here? We evaluate expression. We return that. Therefore, sum of expressions. So let's add a breakpoint in here. Let's remove breakpoint. Actually, I want to remove all breakpoints. We are at 3 hours into the stream. I'm gonna not make this much longer. Just this one last bug we need to figure out. Sum of expressions is 20. So this is what the first line is evaluated. So, and then we shift our expressions as well. That's interesting. Our expressions is an empty array. Why is that? Our inputs. Oh wait, we are not working with but okay. Let's run it again. So our input is about expressions. We get all of these expressions. So our first expression was that, yes, and the sum of that is that, and then our next expression is going to be that, and then we add, we've added that to the part, did we? Yeah, so it's kind of like summing up, and then, all right, there might be another edge case in there that we don't. That is not covered by our example inputs. So, because this looks fine overall. And then sum of expression. What's the answer for second part? What do you get if you add up the results of evaluating the homework problems using these new rules? Yeah. So this is good. This is doing what it supposed to do. I think there's another rule that we aren't really taking into account. So what did we do? We did parentheses. We did multiple parentheses with nested one level inside. We have this is kind of like the same as that. This is nested inside. This is multiple nested inside. Yeah, it's a bit tricky right now because all of our example inputs pass. So I'll have to use our own input. But let me run the program again. Yeah, this is the number we get. Does it overflow? 1,000, 1 million, 1 billion, 1 trillion. I don't think it overflows because number max, what's max safe integer? Max safe integer in JavaScript is larger than that, so it doesn't overflow. So that's not the issue. We're so close to getting the answer for the second part. Really close. There's one edge case here which is failing us. So what are we doing? We're doing as we get an expression and we are evaluating all the pluses, all the additions that we can evaluate. If not, then we evaluate all the multiplication expressions that we can evaluate. And those can be either, and those are going to be inside, okay, inside that, inside parentheses. What else are we missing? What else are we missing? This input looks a bit complicated. Let's try this input. Let's try this input, and I'm gonna add a debug statement before we go into any of these. Let me, I'll do it like this. All right, and then before we do this as well. Okay, so let's run. So our expression is, did I forget to modify it in here? Yep, I did. So our expression is that whole thing. Okay, so do we have an addition expression? We do with 9 plus 4. So we evaluate that. Good. Next iteration, our expression is 13. Do we have an addition expression? We do. It's 4 plus 2. We evaluate that one. That's good. Continue. And then our addition expression is 6 plus 7. All right, evaluate that as well. And maybe I should copy value somehow. Oh, well. Here expression, copy value. Maybe how about like this? So kind of like keep track of every value. So that's our new expression. And what's our addition here? 3 plus 2. 3 plus 2. Where's 3 plus 2 in here? Is that correct? Yeah, it is correct. Okay, so evaluate that as well. And then 5 plus 3, I guess. Okay, evaluate that as well. And then what else do we need to evaluate? 9 plus 9. Okay. Another 9 plus 9 here. And then 18, and then 18 plus 8, I guess. Yeah. 18 plus 8 equals, what are we gonna get here? 26. Right, so we get 26, and then we evaluate 6 plus 9 to 15. Great, so now we're done with addition expressions. We're gonna go into multiplication expressions. We have the first parenthesis in here. We evaluate that into whatever it's gonna be. I guess, yeah, this big number. I'm assuming it's correct. Addition expression, nope. We get another multiplication expression. Yep, let's evaluate that. Great, and then we get another multiplication expression. Evaluate it. All right, so this starts to look pretty good so far. Then no more addition expressions. We do have a multiplication expression there that we need to evaluate. You know what I'm wondering? I'm wondering if our logic is correct for the bigger numbers of like adding them. Let's figure that out in a bit. So we have an addition expression. Yeah, that's correct. So evaluate that. So that should be 4,215. Yep, correct. And now, do we have an addition expression? Nope. Let's go to multiplication. We have that one. So this is going to be like a huge number. Let's see what that's going to be. What is it? 7 times 7 times 6 times 8 times 8 times 4215. So that's this number. Okay. 9913680. Okay, yeah, so that logic works. So that's not where the bug is. Something else. We have an addition expression now here. So we need to add these. All right, another addition expression, add that. And then we don't have one, we have a multiplication, so do that. And then we do have an addition, so add that. All right, so then now we just need to multiply, I guess. But it's we don't have one, we have one here. Yeah, because there's no parentheses, so we just pass this on here. Is it doing the right thing? 5824. Yeah, I guess it should. Yeah, because it doesn't matter if there's parentheses around it or not. Yeah, but let me just verify. Let me just verify that here. Calc. So what is it? 5824 times. Oh, actually, we might reach out of bounds here. Maybe that's the bug. Yeah, we might have to use a big int in the end anyway. Times 84 times 103068 103068 04. All right, so how big is this number? 1,000 to 1 million, 1 billion, 5 trillion. Okay, this might be the bug. Let's run it. We are here. That's the expression. What's the result? I wanna go into that. Okay, left operand, so that's the number that we're about to return. No, that looks correct. Oh wait, 1,000 a million, a billion, 5 trillion. How big is our number here? Thousands, billion, a million, a billion, 7 trillion. Oh, 9,000 trillion. Okay, so no, we're not overflowing. So that looks good, actually. And then we return. Yeah. Okay, so the bug is not for this line. There's one edge case in here that we haven't accounted for, and I'm gonna look it up this off stream. I'm gonna wrap it up because we're already quite 3 hours and 13 minutes into the stream. We're almost there. We're almost there. It's just there's just one edge case in this input. There's one edge case in this input that doesn't give the correct answer given our program. But I have no, I'll have to figure out what that edge case is. It might be something like, maybe there's a triple nested parenthesis somewhere here with a plus at the edge, something like that. I'll have to figure out what it is. I don't think it's something as simple as 7 plus 7. No. Yeah, I'll have to figure out. I'm going to solve this off stream, and then I'm going to push my the answer on this repository, which I'm linking in the chat. If you want to have a look, for folks watching later, it's going to be in the YouTube description. And tomorrow, well, tomorrow is a weekend, so I'm not gonna stream tomorrow. On Monday, next Monday, we're gonna continue with day 21 of Advent of Code. Same time, 10 a.m. Central European time. And then I'm gonna do a recap of days 19 and 20 in the weekend. And I'm also going to do a small recap of today, of what the eventual bug was that I found out. So I'm gonna fix today's solution, and I'm gonna go over it on Monday in the next stream or next video if you're watching this later on YouTube. So yeah, see you then hopefully, and wish you a wonderful Friday and a nice weekend. Bye bye.